Good morning, everybody. So, in today's lecture, we work out some more problems on viscosity so that we understand the concept of viscosity much better. So, let us take the problems on viscosity in this lecture. So, today's lecture focus on the problems related to viscosity. We have already done two problems in the previous class. So this is the third problem that which we are taking. A piston 796 mm diameter and 200 long works in a cylinder of 800 diameter. If the annular space is filled with a lubricating oil of viscosity 5 centipoise. Calculate the speed of descent of piston in vertical position. The weight of the piston and the axial load are 9.8 newtons. So let us understand the problem first. This is 796 is the piston diameter. The piston length is 200 long. Now this piston is rotating inside another cylinder of another cylinder of diameter 800. So there is an inside piston, outside cylinder. Piston is also cylindrical. So this piston is moving inside a cylinder. That piston diameter is 796 whereas the cylinder diameter is 800 How much is the length of the piston that is involved? That is basically 200 long, right? Now, the annular space means the space between the cylinder and the piston walls. The cylinder wall and the piston wall, the space between them is filled with a lubricating oil of viscosity 5 centipoise. Next. What he wants, what is the velocity of the piston while moving down? Right? Right. Next. What is the weight of the piston that he has specified 9.8 newtons? These are the datas. So if I diagrammatically represent the same, for example, the cylinder is outside thing, right? So if I draw, this is the cylinder portion. Cylinder is outside. So cylinder is not rotating, right? So that's why I put it as fixed thing like. If I take this as central axis, now inside this cylinder, the piston is now there. This is the piston. Piston is also cylindrical. Please note that this is cylindrical, not rectangular. So if I draw in plan how it looks like, if I draw it, basically this looks like actually this is the piston basically, and this is the cylinder. This is how they look like. This cylinder is fixed actually, and now the inside one, this is the cylinder. Sorry, this is the piston, and the outer one is the cylinder. The space between them, this is the space. The entire space, this space. So this space, I mean by this is the space. This space is now filled with a lubricating oil. That is the next thing. Then actually, what is the weight of this piston? That's what they have given. This W he has given. So what is this diameter he has given? It is 800 mm. What is the inside diameter? This is 796 mm. And this annular space is how much they have put it? 5 centipoise basically, the mu value. And what is the annular space if I 7 8 mm minus 796 mm 4 mm? So that 4 mm is on this side 2 mm, this side 2 mm, right? So this is the diagram for us. So if I take this as the diagram, let us now write the solution part of it. How to write the solution part? One thing I will take it first. If I take first cylinder diameter is equal to 800 mm. Then piston diameter is equal to how much? 796 mm. What is the distance from cylinder to piston? It is equal to 800 minus 796 by 2, because there are two annular spaces. So that means it is 2 mm. And this is what we call y. It is equal to 2 into 10 to the power of minus 3 meters. Right. This is first one. One thing is over for us. Then what is the length? Length of piston, that is L. L is equal to how much actually? 200 mm. So 200 mm means 0.2 meters. Fine. This is also second one. What is the third one that we can do? What is the viscosity? Mu is equal to 5 centipoise. What do you mean by 5 centipoise? 5 into 10 to the power of minus 2 poise. But poise, we are not supposed to use it in the equations. So it is 5 into 10 to the power of minus 3 Newton second per meter square. Why that answer? 1 poise is equal to 0.1 Newton second per meter square. This is the norm for us. So accordingly that. So what are the remaining things? What is the weight of the piston actually? That weight is equal to 9.8 Newton. So this is what he has given. So mu is known, W is known, Y. So always what we will do for our problems, any of the things, we always write Newton's law of viscosity. So the, because any viscosity problem is, it depends finally on only Newton's law of viscosity. That is the main source for us. What is Newton's law of viscosity? Tau is equal to mu into dv by dy. This also what we can write mu into v by y. This is thing. So what is tau is equal to? It is force by area. Right? Force by area means what is the force actually? It is the shear force. This shear force is nothing but when it is moving for the oil, if I take it, the shear force is nothing but the weight of the piston. It is nothing but the weight of the piston divided by what is which area I should use it? The surface area of piston. What is surface area of piston? Surface area of piston. Piston is what type? It is like a cylindrical. Piston means cylindrical. So that means it is the piston is like this. So if I take this is the piston actually, right? This length is what he has given is 200 mm. So we converted zero point 0.2 meters, and this diameter is diameter is 796 mm. That means 0.796 meters diameter. So what is cylinder area? Cylinder surface area. How much it is going to be? Pi into d into L. So it is nothing but pi into d into L. So what is pi is pi into what is d? 0.796 into L is what? 0.2. This is basically the surface area. So this is base surface area is in meter square. So the what is tau is equal to? Tau is equal to 9.8 weight force by pi into 0.796 into zero point 0.2. Right? This is Newton per meter square. So this is one equation for us. What is the other thing which we are finding out? So mu into V by Y. What is mu he has given? It is 5 into 10 to the power of minus 3 Newton second per meter square. Already we converted. What is velocity? It is unknown. What is y? Annular distance. That is 2 mm. 2 mm means how to convert into meters? 2 into 10 to the power of 3. So this is basically second. So now if you equate tau is equal to mu into v by y. So equate 1 and 2. So what will happen? You see 9.8 divided by pi into d is 0.796 into zero point 0.2. This is on left hand side. This is 5 into 10 to the power of minus 3 is viscosity into v divided by 2 into 10 to the power of minus 3. It is y distance. So if you calculate and simplify it, naturally, V is equal to 7.841 meters per second. So this is one of the very, very important problems on viscosity. So I will take another problem in viscosity. Problem I call it as 4. What is the fourth problem? A cylinder of 150 mm radius. Please see whether the person has given radius or diameter, rotates concentrically inside a fixed cylinder of 155 mm radius. Both cylinders are 300 mm long. Determine the viscosity of the liquid which fills the space between cylinders. If a torque of 0.98 Newton meter is required to maintain an angular velocity of 60 rpm. So let us read the problem and first fix the data. What is the data given? Cylinder, rotating cylinder. If you want, you write like that also. Rotating cylinder radius 150 mm. It is radius, please remember. Then the fixed cylinder, the outer cylinder is fixed. Fixed cylinder radius. How much? 155 mm. It is radius, not diameter. From this 2 itself, you can find out what is y. Y is nothing but from the fixed plate to the moving plate. Fixed cylinder to the rotating cylinder. It is here given radius only. That means one side, half from the half, one side. Suppose if I take it, suppose this is the rotating cylinder. So the outer one is what actually the fixed cylinder. So this is outer one. Right? This outer one is fixed, whereas the inner one is rotating. If I take this is the central axis, the inner one is rotating. Right? So now the data point of view, if I see this diameter radius is 155. Whereas if you take it actually, this is 150. So that means this is how much actually? 5 mm. Right? So it is 5 mm. So 5 into 10 to the power of minus 3 meters. This is the usefulness of these. If he is giving diameter, then total length will come. So two annular spaces will come. Divided by 2 you should put on that. That is first. Then second one is length. So this length he has given it as how much? Basically 300 mm. Am I right? Let us see. 300 mm. So L is equal to 300 mm, 0.3 meters. What is the use of this length actually? The length is for us only one purpose, to calculate surface area of moving cylinder. This is the purpose. So L also over. What is the next he has given? Determine the viscosity. So question is what? Mu is equal to how much? What is the other data he has given? If a torque of 0.98 Newton meter, torque 0.98 Newton meter, right? So what is torque actually? What is torque? You should understand. Torque is equal to, what is the torque? Torque is equal to force into lever arm. What is the lever arm here? Radius. So whatever radius is there, the cylinder radius which is rotating, that. So when I write, it is only the rotating cylinder radius. Fixed cylinder dimension is required only to calculate y. Otherwise, the fixed cylinder thing is not for us any calculation. The fixed cylinder radius or diameter are required only to calculate y value. Please remember, L is required only to calculate the surface area. But torque is what he has given is to calculate the force. Right. So by using this, again, how we will get shear stress? Tau is equal to force by area. Which area this will be? This will be surface area. Because it is shear stress. It is tangential force by surface area. So this is what problem. And last one he has given it is what? The angular velocity. Angular velocity is in which units? RPM. But what we require is what? Tangential velocity. So tangential velocity in meters per second square we require. So what is the relation between tangential velocity and angular velocity? Tangential velocity is equal to R into basically angle omega. Right? This omega also we have to convert into first radians per second and then multiply. So how to get omega? It is equal to 2 pi n by 60. So how to get it? 2 into pi into n is 60 divided by 60. So this is omega. Then how to get tangential velocity? Tangential velocity is equal to the radius of the rotating cylinder. Radius of the rotating cylinder is what? 0.15 basically into 2 pi into 60 by 60. This is R omega. So this is 1. So this will be in meters per second. So now let us go to our equations, right? So Newton's law of viscosity. Each dimension y he has given, you have to see tau is equal to mu into dv by dy. Tau is equal to mu into v by phi, right? But given one is torque. So given is torque. Then how to get tau? This is the question. Already I mentioned torque T is equal to force into radius. What is force? I mentioned actually force into radius. And then if that is the case, what is the force? I don't know. Torque is how much he has given? 0.98. 0.98 is equal to force into radius is how much? 0.150 because radius of that. So if that I put it, right? This I put it. So now basically uh, force. And what is force is equal to 0.98 is equal to force. What can I write? Tau into surface area. How basically tau is equal to force by area. So therefore force is equal to tau into area, right? Into 0.150. So it is tau into surface area is what? Pi dl into 0.150. So tau into what is pi into d is how much? Basically, it's not radius. 0.150 into 2. This is the diameter into radius length is how much? 300 mm. So that means zero point 0.3. So this is dl into radius 0.150. So this is one equation. So therefore tau is equal to 0.98 divided by pi into 0.150 into 2 into zero point 0.3. This is basically pi dl, right? Into 0.150. So I better write this as 1 because our first equation is always should be talking about shear stress, right? Now let us go into second one. Second one is what? Mu into v by y. So what is mu? He has given mu, we have to calculate. So mu into what is v? I mentioned v is nothing but r omega divided by y. So again what I mentioned mu into r R into omega is what? 2 pi n by 60 divided by y. So now if I substitute what I can substitute, R is equal to 0.150 into omega is equal to 2 into pi into 60 by 60 divided by what is the thing? 5 into 10 to the power of minus 3. So this is second. So this is the second equation. Now basically we know tau is equal to mu into v by y. So equating 1 and 2, what we will get? The first one is what? Tell me. 0.98 divided by pi into 0.150 into 2 into L point 3 into or 0.150 is equal to mu into 0.150 into 2 into pi into 60 by 60 divided by 5 into 10 to the power of minus 3. So only unknown is what? All this you can calculate. All this unknown is only mu. So therefore, mu is equal to, if you calculate, it is 0.123 Newton second per meter square. Please try these type of problems actually. I go into the next problem. Four problems we have solved. Let us take one more problem. The fifth problem. The fifth problem is such that a space 25 mm wide between two large plane surfaces is filled with glycerin. What force is required to drag a very thin plate zero point 0.75 square meters in area between the surfaces at a speed of 0.5 meters per second. If this plate remains equidistant from the two surfaces, take mu is equal to 0.785 Newton second per meter square. So let us check what is given. A space 25 mm wide, right, between two large plane surfaces, fine, is filled with glycerin, fine. What force is required to drag a very thin plate of this area between the surfaces at a speed of this much? If this plate remains equidistant from the two surfaces, right? Fine. I will draw the figure. This is a plane. This is a plane. What I have done? This basically between these two, what we have filled up glycerin. So this space, total space is how much he has given? Total space he has given it is 25 mm. Fine. Now, what he has done, a square plate of area 0.75. So this is the area. Regarding the thickness of this, he did not specify. So this is dragged, or this plate remains at a speed of V is equal to zero point 0.5 meters per second. Fine. Another thing, this plate area is equal to A is equal to 0.75 square meter, direct, nothing to do. What is the plate velocity is also zero point 0.5 meters per second. So unit also correct. Right. Next, what is it asking? Mu he has given 0.785 Newton second per meter square. So this is also straight, no conversions, nothing here. What more he has given? Absolutely no problem. So if I just to understand, this is the fixed plate, this is the moving plate. This is the fixed plate, this is the moving plate. It is kept equidistant. So what is this distance actually? 12.5 mm. So what is this distance actually? 12.5 mm, because thickness is not given. Next, when this is drawn, how the velocity distribution will be basically, if I draw, if this is the case, how the velocity from the at the fixed plate velocity is zero. Whereas at the moving plate, the velocity will be like this is how the velocity distribution is. Right? That is how zero point 0.5 at the center. Now, what he is asking us is uh, force is equal to how much? What is the force we have to use on the plate to draw it? So now if I consider what is y for me, this is y. So there are two problems here. The between the fixed plate and the moving plate, if I take the top zone, this is zone 1 if I take it. This is zone 2. So zone 1 is separate, zone 2 is separate, right? Because of this glycerin which is filled between these two, naturally the shear force will be there on the upper plate like this. Shear resistance will be there. Whereas similarly the shear resistance will be there. So whatever force you are using should be equivalent to, if I calculate the shear force for zone 1, I come calculate it as F1. For zone 2, F2. What is the total shear force is equal to? Total shear force is equal to, for zone 1 F1 plus zone 2 F2, right? That is what. So for zone 1, let me calculate. So if I calculate what is tau 1 is equal to, tau 1 is equal to, what is the equation for us? Mu into V by Y, right? That is tau 2 is what actually, again mu into V by Y. So mu is same, but only thing is in this particular problem, y1 y2 also both same, velocity is anyhow middle. So this, so now if I put it, what is tau 1? I will get it, tau 1 is equal to mu is 0.785 into what is V 0.5 divided by What is y1 actually? It is 12.5 into 10 to the power of minus 3. Why minus 3? Because mm he has given. Now I am converting into basically meters. And again, remember total space he has given. But y means what for us? This is y for this zone. This is y. What is y? Y is the distance between the fixed plate and the moving plate. So this zone only straight, this zone. Similarly, what is here? It is 0.785 into zero point 0.5 divided by 12.5 into 10 to the power of minus 3. So now what is total? Basically, if I want, what is force F1 is equal to tau 1 into area. So what is tau 1? 0.785 into zero point 0.5 divided by 12.5 into 10 to the power of minus 3 into area is what he has given, 0.75. This is newtons. What is F2? F2 is equal to tau 2 into area. Area is same. So 0.785 into zero point 0.5 divided by 12.5 into 10 to the power of minus 3 into 0.75 newtons. So therefore, F is equal to almost this and this are same. It is nothing but 2 times F1 or 2 times F2. Anything is same. So therefore, if you calculate this, the total force is equal to, which I will get, it is equal to F1 will be equal to 23.5 newtons, F2 also equal to 23.5 newtons. So F is equal to 23.5 plus 23.5, it is equal to 47 newtons. Wonderful question. In this question, there may be a little twist also in the exam. So instead of keeping at the center, they can keep at, for example, the plate is at 10 mm from the upper plate and basic upper plate. So in that case, this y1 becomes 10 mm, y2 becomes 25 minus 10. 25 minus 10 is equal to how much? It is equal to 15 mm. So again, but that's why I calculated, I never take it as 12.5, 12.5 equidistant. Suppose if it is different, so instead of 12.5 here, it will be differing. Apart from that, there is no other change. So whatever is the distance in zone 1, distance in zone 2, we have to put it and solve the problem. So this is an excellent problem, another problem that which we should remember. So last problem, I will take one more problem and close this topic actually. A 90 mm diameter, all I have done, the shaft rotates at 1200 rpm in a 100 mm long length journal bearing. Why I am giving these number of problems is only to make you where this application comes. Journal bearing of 90.5 mm diameter. The angular space in the bearing is filled with oil having a A dynamic viscosity of 0.12 Pascal second. Estimate power dissipated. Why I have taken up this problem? I will explain. The first problem I concentrated only on force, today's problems. The next problem I have taken you to torque. Torque is nothing but wear into force into radial distance. The lever arm. In the first today's first question, I have straight away given you the velocity. But in the second problem, I have given you in terms of RPM. So when RPM is given, you should first find out omega, angular velocity. Angular velocity is how much? 2 pi n by 60. Once angular velocity is obtained, then actually the tangential velocity is equal to r omega. That we need to check it out. So one, that's how each problem when we are giving, there is some basically something which you should understand extra. In this problem, why I have given is this is one more point I brought in. The power dissipated, which is generally one of the most important thing that we will be interested actually. So what we will do in this, how to go about that we will see, right? First, the shaft, rotating shaft means this is rotating shaft 90 mm. So first thing is what we should write actually solution if I put it. Rotating shaft, rotating cylinder, shaft, cylinder, piston are all cylindrical only. Rotating shaft dia is equal to 90 mm. What is the next one? Basically, the journal bearing diameter. That means this shaft is rotating inside a journal bearing. So, journal bearing is nothing but the fixed cylinder like. This is 90.5 mm. So, the journal bearing means this is fixed. This is rotating. So, that is what you should understand. Here, given is diameter. So, what is y is equal to? Y is equal to difference of diameter 90.5 minus 90 divided by 2. Why 2? Because the annular space on one side radius 1, the second side 1. So that is why our y is what? Only one annular space. That is why it is written. So it is 0.25 mm, which is equal to 0.25 into 10 to the power of minus 3 meters. That's first thing. What is the second thing he has given? This is rotating at a speed of 1200 rpm. So speed means always for us actually we should put it as n. And then once n is given, how to get v is equal to r omega. It is r into what is omega is equal to r into 2 pi n by 60. So R is what actually rotating cylinder. Rotating cylinder diameter is 90 mm. What is radius? 45 into 10 to the power of minus 3. Why 10 to the power of minus 3? It is only to express in meters, right? Into 2 into pi into n is 1500 divided by 60. So this is in meters per second. So each one we see how we are getting actually. V and Y we got it. So what is our next one? Mu. What is mu? He has given 0.12 Pascal second. Pa means what? Pascal. What is the relation between Pascal? Basically, Pascal, Pascal, which is written as Pascal, means actually Newton per meter square. That is what I mean. So, what it is? 0.12 Newton second per meter square. So this Newton per meter square is nothing but actually this will be Pascal, right? Into second over. So mu is straight away given. So what is the other thing which has been given in this? I don't think anything is given in this. No issues. So now let us go straight to our problem. So what is the Newton's law of viscosity? Anything that we can draw slowly from there. Newton's law of viscosity. We will take it. What is Newton's law of viscosity? If I take it, Newton's law of viscosity, tau is equal to mu into V by Y, right? So therefore, tau is equal to mu into V by Y. Mu is equal to 0.12 into V is equal to, already we have written it as 445 into 10 to the power of minus 3. This is R into omega is 2 into pi into n is 1500 divided by y is 60 into y is how much we have put. It is 0.25. 0.25 into 10 to the power of minus 3. Why 10 to the power of minus 3? To convert mm to meters. So this is our tau value. So if I put that tau value, then naturally we will get this tau. You can calculate what is tau then. But what he asks is for power. If I want to get power, then I need force. Tau is equal to force by area. That means the force by surface area. So how I will get force is equal to shear stress tau into surface area, because I always calculate at the end what is shear stress is equal to, because if you want to calculate quickly, calculate at the top. Otherwise I will write 0.12 into 45 into 10 to the power of minus 3 into 2 into pi into 1500 by 60 into 0.25 into 10 to the power of minus 3. This is shear into surface area means pi dl, right? So this multiplied by pi dl means pi into d is how much actually. D is rotating diameter, how much it is? 90 into 10 to the power of minus 3 diameter, right? Into L, what length he has given? 100 mm. So it is nothing but actually 0.1, right? So that means force also we got it. Once force we get it, actually power is equal to, you can put force into, there are different formula. It is into velocity. That is one you can put it actually. Or power is equal to, there is other way also. Power is equal to, basically we can put uh, torque into angular velocity. Torque is nothing but again force into, right, radius into angular velocity. This radius into angular velocity is nothing but actually it is our velocity. So directly you can put force into velocity. So this, if you try this, you are going to get power is equal to, finally the answer will be 217.06 watts. Please try this calculation. Already force you got it. Force already velocity. If you get it already r omega, straight away substitute it. There are two ways of getting force. Any method is same. So this straight away you can get the answer. So this is with this I will stop, but I will give you one more question also to you at the end, which I will not solve. This question is how much number we should give to this previous. The last question I will take it up. Almost this is around the eighth problem which I am taking to you. The last 2 days. This also I will not, you can calculate. Calculate the approximate viscosity of oil for the following case. Very, very important. So there is a plane like this. There is a weight. This is the weight. This problem I have solved actually. Only thing is for your understanding sake. The slope of this, they have given it like this. This theta is equal to 5, 12, 13. And this velocity is equal to, here has given zero point 0.5 meters per second. Has given this gap. This gap is filled with some oil of viscosity that he wants us to find out. So this viscosity is how much? Question is that. Then you can ask me what is this gap is. This gap is 0.15 centimeters, right? Last thing he has given is this weight. He has given it as 150 newtons. I show the figure also. So this angle is theta. This is the component. So this is W sine theta. F is equal to W sine theta. Tau is equal to force into area. For getting area, basically, it is 1 meter by 1 meter square plate. So force into force, area is 1 meter square. So this is Newton per meter square, right? Then after tau, you are getting tau is equal to mu into V by Y, right? Mu is unknown. Tau is equal to W sine theta into 1 is equal to mu into V is, or he has given it as zero point 0.5 divided by mu by y is equal to 0.15 into 10 to the power of minus 2. Because centimeters has given, I am converting into meter. So what is mu? That mu is equal to, answer also I will give, 0.17 Newton second per meter square. Right. And how to get basically the theta value is equal to tan theta or sin theta, you can calculate. You can do, right? So now if you take it basically here, tan theta is equal to, if you want tan theta is equal to 5 by 12. Or sin theta, you want actually, theta is equal to opposite side by hypotenuse, 5 by 13. So then accordingly you work out the problem. So with this, I complete the problems on viscosity, and we will go into the next topic. So we have completed the topic viscosity. We will take up bulk modulus, compressibility, and vapor pressure in the next class. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.